So once you complete all the nonlinear modeling, then you go to define and then load cases. Let me add a new load case for nonlinear dynamic analysis. So you select time history, give it some name, and then in that you can say subtype or solution method. You can either select fast nonlinear analysis FNA or nonlinear direct integration. FNA takes significantly less time compared to direct integration because it uses a different solution method to calculate dynamic responses, just like linear model and linear direct integration. So let me select FNA, and then just like any nonlinear case, I can start that nonlinear analysis from the initial zero conditions, or I can start it from the end of another nonlinear analysis, right? So if I go for the second option and select some other nonlinear analysis in that list, the program will first apply that nonlinear load case, and whatever is the degraded stiffness at the end of that nonlinear load case, the software will use that as the initial stiffness to apply this new load case which you are defining here, right? So this option is sometimes used to apply gravity load first prior to the application of seismic load in nonlinear analysis, right? So in nonlinear analysis, we know that the order of application of loading matters, right? So if you want to perform nonlinear dynamic analysis, first you have to apply gravity load to your model, and from the end of that application of gravity load, you should start applying the earthquake, right? So how you will ensure that first you make a nonlinear gravity load case, declare it a nonlinear load case, then while defining the earthquake load case, you will be able to select that nonlinear gravity load case from that list, right? So let me quickly do that. Add a new load case, and then let me give it name nonlinear gravity. Let me select its type as nonlinear static. So gravity will be applied still as a static load, but the analysis will be nonlinear. And key feature of nonlinear analysis is that not all the load is applied simultaneously. It is applied in steps. Because the structure is nonlinear, it have the capability to yield or crack. So the load is applied step by step and up till the complete load, and then when whatever element is yielded during that process, its K is degraded, stiffness is degraded, right? So we will select nonlinear static as the type of analysis, and then let me start that nonlinear gravity from the initial conditions. Add the gravity load pattern. Let's assume that dead is representing my all gravity load, right? Or maybe dead plus live. So let me add dead and live both. Scale factor 1. So what I am saying, that apply dead plus live, but apply it in a nonlinear static manner. Start with a very low number, and then in step by step manner you apply the full dead plus live, right? And the model should be nonlinear, obviously, before actually making that case. Load application can be full load, and result saved can be final stage or multiple stage. Let me skip that. There are some nonlinear parameters which we can discuss some other time, but they actually affect the convergence of the analysis. Modal load case may be required, so you can select that one. P delta if you want to include geometric nonlinearity, so you have option for P delta and then P delta plus large displacement, so maybe we can select P delta. So once I click OK, this nonlinear gravity load case is defined, which is simply saying that apply dead plus live load in step by step manner. The number of steps are already defined in the nonlinear parameters, which you can modify later also. Maximum total steps is 200, right? You can just give maybe 100 or maybe some 50 steps. So it is in your hand. So what program will do, it will apply that full dead plus live in 100 steps, right? So start with a very low number and give it increments up till full load in 100 increments or 100 steps, right? And during that process, if any beam or column yield as defined by its plastic hinge, then its stiffness will be degraded by the program. So I click OK and then click OK. Now this nonlinear gravity load is defined already. Now let me add a nonlinear dynamic analysis load case. So let me select nonlinear time history, maybe let me select fast nonlinear, and then continue it from a nonlinear case, and let me select maybe I should go for nonlinear direct integration, and then I can go for nonlinear gravity, right? So now I am telling the program, apply the earthquake, but first apply nonlinear gravity case and take the stiffness of the structure at the end of nonlinear gravity case and use it to apply this new load case, which is nonlinear dynamic case, right? And here I'll add a acceleration pattern in a particular direction defined by a particular function. This should be my time history, earthquake time history, with an appropriate scale factor, and all other things are same except this nonlinear parameter is now added. So that again, nonlinear parameters, if I click, there are several factors which affect the convergence and ultimately the analysis time also. So we can discuss that at some later stage, but ultimately the form to create a nonlinear load case, nonlinear dynamic analysis load case, is very similar to what we have for linear time history, right? Except these two major changes, that we now can start the analysis from the end of any preceding nonlinear load case, and also there are additional nonlinear parameters which we can use the default values unless we get some numerical convergence error, right? So most of the time you don't need to modify any nonlinear parameter, and all the other things should be very same as the linear time history analysis. So now you have already defined a nonlinear direct integration history. So now the model can be run and the hinge results can be seen after the analysis. So we will have a separate demonstration on how we can see the nonlinear analysis results once it is run already, right?